702 and Cape Talk.
The Naked Scientist.
6 minutes after 10, it is time for The Naked Scientist indeed, where we answer your questions from the world of science. Good morning, Chris.
Good morning.
You sneaked into the country without dropping in
I know.
for a cuppa.
I know. I snuck in. It was a flying visit, Eusebius. I went to Durban actually because it was a BioAfrica conference. It's the inaugural conference. The aim of this is to try to increase the emphasis on biotechnology, the interaction between businesses, biologists, scientists, industry across the African continent and the rest of the world. So there was a sort of multinational group of people who attended the conference. It was really good, actually. And it was my first time in Durban. I've never been to Durban either, and the weather there. Wow. Why have I been going to Joburg and places like Grahamstown? The weather, although we don't call it that anymore, do we? The weather's fantastic.
It is absolutely stunning. And along the way, you met what sounds like an interesting chap from the University of Pretoria.
Yeah, I did. I won't let the cat out of the bag too much at this stage because what they're going to do is they are launching a company. They've got the company off the ground, but the product launch is going to come soon. But I bumped into this guy, and this is why these conferences are so important. This chap just stopped me and said, "Hey, Mr. Naked." And I started talking to this guy he's from Bulawayo in Zimbabwe, but joined the University of Pretoria. He's a chemist. And what he has done is to invent a pair of socks, or actually other yarns. You can spin this yarn into anything, and it has a very oil-loving core to the material he's invented, which will bind insect repellents very well, and it's sandwiched inside a oil-hating layer, which keeps the stuff inside. So what you can do is impregnate the oil-loving layer with an insect repellent like DEET, but they're actually using something else as a alternative. And it slowly diffuses out the insect repellent. And since about 93% of the time, he told me, mosquitoes bite people on their ankles, you could wear this pair of socks and it will, over a number of months, not just a few weeks, but up for 8 months, it will continually slowly release the repellent, protecting your ankles, and in the longer term they're going to make puffs for arms so that you can protect your elbows and upper arms as well if you're out working in the bush or going walking and that kind of thing. So this is a wonderful sort of spin-out story from the University of Pretoria because they have invented the material that's made this possible. And obviously the market's going to be huge because mosquitoes are the world's most dangerous insect. They are responsible for more deaths and disease owing to the diseases that they spread than any other organism. So just an amazing story, and they're going to extrapolate this to other kinds of applications like even bed bugs. So they'll solve that crisis too, hopefully. But when it launches, I'll come back and tell you more about it.
Great stuff. We've got lots of calls already. Steve, good morning.
Good morning, guys. Thanks for taking my call. I really appreciate it. My question is about an atom. Atoms are, everything is made up of atoms, rocks, metal, roads, whatever. Now, do they die, or are they there forever and ever and ever and ever and ever? And also, just your points on that the Earth is actually, and the Sun is a nucleus, and the Earth and the Saturn planets are the electrons are spinning around it. So we are actually an atom in a bigger body, which is the rest of the universe, which are more atoms.
Hello, Steve. And you should never believe anything an atom tells you because they make up everything. But
I see what you did there.
It is a little bit confusing, all of this, but what we know about atoms is that they're made, you just need 3 fundamental particles. And although there are many fundamental particles out there in the universe, we can make the matter that you see around you from just 3 of them: up quarks, down quarks, and electrons. And that's all you need to make neutrons, protons, and therefore atoms, because atoms are a dense nucleus with 1 or more protons and 0 or more neutrons, depending upon what type of atom you're dealing with, and then a cloud of electrons, or in the case of hydrogen, a single electron associated with that nucleus. Now, you cannot destroy an atom because those particles are going to exist, but what you can do is have one type of atom turn into another type of atom. What do I mean by that? Well, if I handed you, I wouldn't hand it to you, I'd probably be wearing a gauntlet with lead in it if I did, but if I handed you a radioactive atom, in that case, what you've got is a nucleus, which is a certain number of protons and neutrons. If you have an unstable combination of protons and neutrons, so uranium-235, for example, this means that there is a chance that that nucleus wants to fall apart. It's not stable, and at random, a nucleus will disintegrate, and it will split into daughter nuclei, or radionuclides, and the mass of both of those, when added together, will add to the parent one, so it sort of split itself in half. As it's done so, it's released some energy, but what you've now got are two new atoms which have got different combinations of protons and neutrons in their nuclei. So an atom hasn't died, but it has converted by radioactive decay into new species of atom. But the particles that make those things up haven't gone anywhere. We don't know why they exist. We don't know why they have the properties that they do, but they endow atoms with the ability to be the atoms that they are.
Annette, thank you for calling in today. What is your question?
Good morning, Chris. Good morning, CBS. My question is very popular at the moment as intermediate fasting, is what they call it. It's you fast for 14 hours every day and then you're only eating the balance of the hours. How does that impact on diabetics that are insulin dependent with type 2 diabetes?
Hello, Annette. Obviously, diets come and go in fads because what we do know is the entire world has a weight problem, and maybe 1 in 3 people worldwide is now overweight or obese, and this carries with it a huge risk to your health because of things like metabolic disorders, diabetes, and therefore high blood pressure, stroke, and so on. So people are looking for ways to solve the problem. The simplest way to solve the problem is to make sure you remain active, because the more activity you take, the more calories you will burn, but also you boost your lean tissue, your muscle mass, which is what burns calories in the first place. So activity is very important, and regulating how much food we eat is also fundamental to this. So eating a healthy diet and having a very diverse diet with lots of fruit, vegetables and fibre in the diet, as well as just proteins and things, is good. But obviously, if people have got health problems, what do they do to optimise their health? And how do they shed the excess pounds if they've got them? Well, the simple answer is that there is no simple answer apart from to do what I've suggested, because there are lots of quick fix type diets. But I think probably the most sensible piece of advice I can offer is you need to aim for weight loss at a sensible rate. You need to do this by eating sensibly and try and get your body taking in calories at a sensible rate at the right times of day. Because what we have learned in recent years is that when we eat at the wrong time of day, your body handles the energy in a much different way. In other words, if I have loads of calories at night time when I'm going to bed, then actually the body doesn't really know what to do with them because I'm going to be inactive when I'm asleep. But also the metabolism is not geared up to process or handle those calories. It handles the calories in a very different way. So the most sensible advice is to front load your day with a relatively protein-rich breakfast. So boiled egg on toast, for example. Bacon even. Not all the time, just occasionally, but protein-rich breakfast, then a modest lunch and have a more trivial dinner. So they always say, the old adage is, have breakfast like a king, lunch like a prince, and dine like a pauper, because actually your body is receiving the calories it needs for the activity and the metabolic profile it's got at the time in a much more logical sequence. And then you can also regulate your calorie intake. I think the reason that starving and fasting yourself works to translate into some weight loss is that if you're fasting, you're very compliant. You know if you've cheated because you've eaten something. If you haven't eaten anything, you've fasted. So it's very easy to get control over the calories you take into your body when you are fasting. And that's probably why people, when they fast or go on these quite stringent diets, actually succeed, at least initially, because it's much easier to keep an eye on what you're eating, and you have more awareness of what you're eating and taking into your body.
Penny, good morning to you.
Good morning.
What is your question? Welcome to the show.
Thank you very much. I would like to know, if you burn polystyrene, are any gases given off while it's burning, and if so, what are they?
Oh, hello, Penny. Well, polystyrene is a polymer of the monomer, which is the building block, called styrene, and you polymerize it by making the double bonds in one part of the molecule translate into a single bond between two adjacent molecules, so they all link together like beads on a string. And when you burn the polystyrene, you are adding energy which breaks some of the bonds, and because it's a source of carbon, it can react with oxygen to produce carbon dioxide. But often the temperature of the burn process is insufficiently high to completely break apart the molecule and turn it all into carbon dioxide and water. So there's often unburned hydrocarbons, bits of carbon and soot left behind. So when you burn polystyrene, you'll see it often gives off nasty, acrid black smoke. So you definitely don't want to breathe that because it's not at all good for you. I don't know exactly what the chemical species are that will be produced. There'll be a range of them. But if you burn it at very high temperature, you'd minimise that. But most people, when they burn polystyrene, don't get anything like those temperatures. So you're potentially liberating soot and other nasty forms of carbon that will have health consequences if you breathe them in regularly.
702 and Cape Talk.
The Naked Scientist.
Indeed, the familiar voice of Chris, and of course we do this every week. You got a question for him? You can call us right now, Cape Town, 021 446 0567. Or if you have a science question for the Naked Scientist here in Johannesburg, the number to dial is 011 883 0702. You can also drop us your question maybe on the WhatsApp line, 072 702 1702. Paul, good morning to you. What is your science question?
Good morning. How are you?
We are good, thank you, Paul. Go straight ahead.
Okay. My question is on Mars. I'm wondering, since it's having 96% of carbon dioxide, is it possible to send trees up there to convert the carbon dioxide to oxygen and make the planet a little bit more habitable?
Which planet, Paul?
Mars.
Oh, I see. Okay. Did you get the question, Chris?
Yeah, I did. I mean, the old joke is you couldn't have a party on Mars because there's just no atmosphere. But actually, that is really true. There really isn't. The atmosphere on Mars is incredibly thin. So while Paul is correct that there is a lot of carbon dioxide, relatively speaking, in the atmosphere on Mars, the thickness or density of the atmosphere is a trace of what we have on Earth. So we have more than one problem of just there being carbon dioxide on Mars to solve. The big problem is there's just no atmosphere. So we'd have to create one in the first instance by liberating gases, carbon dioxide, water, and ultimately oxygen from the planet's surface. The other issue is that in order for trees to grow, they need a habitable climate. And the trees that we have on Earth have evolved to survive within a fairly narrow temperature range. They can survive at around freezing or even 40 below, but they don't grow at those temperatures. They need the warmth that comes with spring and summer to put on growth. And they need a reasonable intensity of sunlight in order to drive that growth. The average temperature on Mars hovers around zero. It's way below zero at night time, and in the daytime it's barely above zero. So Mars is a very frigid, cold place. So not only is it free of an atmosphere, not only is the atmosphere sparse and full and dominated by CO2, it's extremely cold, and there's no radiation protection in the form of an ozone layer or a magnetic field to fend off other kinds of radiation. So anything you tried to grow there would be bombarded with radiation unless you took steps to solve that one too. So terraforming Mars, while it's a nice idea, is at this stage, we think, totally unfeasible and certainly would take a very long time, as in on the scale of hundreds of years to achieve.
Sean, welcome to the show. Hello, Sean.
How do you, CBS? How's it? The other day you had a guest on the show discussing, not eating meat. And the question for the scientist is, how critical is fat for the development of a baby's brain?
What kind of fat, Sean?
Well, what kind of fat? Animal fat.
Okay. Oh, okay. Gotcha. Yeah.
Hi, Sean. Well, obviously, when a baby is developing, it develops inside its mum. And the role of the mum and the placenta that connects the baby to its mum's blood supply and is the route through which the baby extracts all of the necessary calories and the relevant building blocks to make a baby, the job of the mum is to make sure that those raw materials are available to the baby. So as long as the mum is well nourished and well fed, the baby will be fine. After birth, of course, you're feeding babies largely for the first 3 to 6 months on breast milk or some kind of milk-like diet, because that's what their digestive system is adapted to acquire calories from, and all mammals work like that. And then once you're about 3 to 6 months old, people begin to introduce solid foods and slowly build them up as the intestine matures, as your microbes in your intestine mature, and the ability to handle calories in that way begins to mature. Now, in terms of the requirement of fat, if you look at mammals like cows or whales, then the breast milk that they feed to their young has a very high fraction of fat in it, because fat is very calorie dense. You can pack a lot of energy into the bonds in a fat. It's a very dense way of passing energy to something. And animals like cows and whales that have to do a lot of growing have a lot of fat in their milk, because it's one way of getting enormous amounts of energy into your offspring quickly. Now, you're quite right that the brain is very much a fat-dominated organ. We have lots of fats in our brain because the nerve cells have membranes, and those membranes are made of oils. The nerve cells are also insulated by a substance called myelin, which is a fatty material, a bit like the insulation you find around an electrical wire. So yes, fat is absolutely critical, but the fats you largely need for that process you can make in your own body, with a few exceptions, which are things like omega-6 and omega-3 fatty acids, which are dubbed essential fatty acids. You derive those through your diet, and so your mum does need to be eating a healthy diet to get those things, but you don't need to be pigging out on a massive steak every day to get those things. You can get them from a range of sources, including fish, for example. So you don't need exclusively meat to have a healthy baby. Fish will do too, but a balanced diet is probably the best thing.
Yaku, good morning to you. Welcome to the show.
Good morning, everybody. My question is this. In the perfect world of Eusebius Macaiza, where there's no war and people tend to live to the age of 100 years, and scientists have perfected science to the point where people just don't die before 100, how long will it take for the planet to be overpopulated to the point where it cannot sustain life anymore?
Well, one could argue we're already at the point where the planet is overpopulated and we can't really sustain life, because we're probably using resources at the rate of many planet Earths every year. The ideal carrying capacity for the planet, I think, and this is a speculative number, I think is a couple of billion humans at most, and we're currently on our way towards 8 billion. So we've got 7.2 to 7.5 billion people. The rate of population growth is about 1% per year, and that doesn't sound like very much, but actually, if you do what the banks use as what's called compound interest formula to work out how much your money's going to be worth next year and then the year after and the year after, if you do that formula and you put the numbers in, you can calculate that it will take about 75 years at current rates of population growth for the Earth population to double. Now, that's assuming that people live for about 75 years. Now, if your people began to live indefinitely, then obviously we're going to get there much quicker. So I would say probably half that time, because people are just not going to die off in the space of a human lifetime. So the answer is, it's a slightly hand-wavy answer, but in under 75 years, so in under the lifetime of the average human, we could have twice as many people. That's way over what we know the Earth can already sustain, and we're probably already at 4 times the amount the planet could healthily sustain without us taking steps not to do even more damage. So it is now our time to act, because if we don't, we're going to mess the place up. There's no going back.
Okay, 24 minutes after 10. 011 8830702 if you want to sneak in a question for the Naked Scientist, Cape Town, on 021 446 0567. Prescott, good morning.
Yeah, good morning, you CBS man. Yes, I just wanted to know from the Naked Scientist. I often used to astral travel, you know, when you're in a sleep paralysis mode, but you actually sort of awake. So when I astral travel, I feel like I'm in control, that I can sort of visit places I need to visit, or so I always feel that I'm in danger, and I fight to retract back into my body. So I want to know from a Naked Scientist, can one sort of leave the Earth's atmosphere when you're in that state? And is there a danger of, dying? Because I do believe, I read years ago, there's an invisible thing attached to something in your brain that, you can control it. So.
Okay. Chris, what is astral travel?
Well, there is this a sort of semi-dream state. People call it lucid dreaming. And the idea is you can have all the benefits of dreaming and do all the kinds of nefarious things that you want to do in your dreams without actually doing them. And you can nonetheless experience many of the emotions and feelings and excitement that would go with doing those things, but without actually doing them and engendering and encumbering any of the risk. You never leave your body, and this is a wonderful example of how powerful your brain is and how easy the brain is to fool itself, because basically when you are dreaming, the parts of the brain that decode emotions, sensations, thoughts and feelings when you are awake start to act almost independently and autonomously, and they generate random signals and information and stimuli, and so you experience those emotions as though they are real because they're being presented to your unconscious consciousness. So you experience the thing as though it were really happening to you, but when you wake up, of course, you realise none of it's happened. So there is no risk to you whatsoever of doing this. It's purely a dream state. It's your brain. We don't know why we dream, but it's probably your brain making sense of a lot of the information that it's had to process during the day and deciding what it's going to throw away and what it's going to keep and consolidate, i.e. preserve for the long term.
Makes sense. Ray, good morning to you. Welcome to the show.
Hey, thank you. I was fascinated by Chris's response to atoms, and I wondered how entropy, which apparently will result in the whole universe, our galaxies, everything being burnt out, the whole universe just a burnt-out husk, and that includes all the atoms. And yet you say that the atoms are able to become something else. So I'm very confused.
I'm sorry about that. Well, there's an interesting tweet which we also got from Ronnie M, who's at Bonderai, who says, if I keep going in one direction in space, will I arrive back at the same point? Because for a long time, scientists didn't know if the universe was a bubble, and therefore if you went round the outside of the bubble, would you come back to where you started? The suggestions we have are that actually the universe is pretty much within 0.4% or so, error of margin of error, we think flat. So in other words, if you start going somewhere in the universe, you'll just continue going in the universe. At the moment, the universe seems to be getting bigger and expanding, and the older it gets, the faster it grows. And so that suggests that we are moving towards a state of more disorder, everything being more spread out, and in millions to billions and billions of years, we might be looking out on a universe that's growing so fast that the stars are so far away from us that the universe is growing faster than the light coming from those stars, so we won't ever be able to see them. So you can imagine looking out into the night sky and you wouldn't see anything. Now, that whole concept of entropy, it was a concept that was proposed by a guy called Boltzmann over 100 years ago, and it explains why things want to happen. They want to happen because there is a movement from order or compactness towards disorder. And things will only happen spontaneously if there is more disorder or more disarray at the end of the process. So I'll give you a simple example. If we take, say, a chemical, it's a solid, like some salt. The reason that salt wants to dissolve in water, I say wants in inverted commas, the reason it wants to dissolve in water is because when it's in the form of a crystal, it's highly organised, highly concentrated and all in one place. If I put the salt in water, the particles, the sodium and the chloride ions that make the crystal, have the chance to disperse or spread out in the water, and that means they're much less organised, there's more disorder, and therefore it's energetically favourable for that to happen. And that's why that reaction, that process occurs. So in the case of atoms, the Big Bang turned energy into matter in the universe, and once the universe was sufficiently cool, they could condense to make the atoms that make up the universe. We know that much happened, but they're constantly spreading themselves out and moving to a state of more disorder and a lower energy state overall in order to satisfy the rules of entropy. So yes, the universe is blowing up bigger, it's getting bigger, and we could be looking at a cold, dark place to live in billions of years' time.
We'll take our final question from Twitter. Here's one from Ryan Langeveld. Ryan says, please ask the naked scientist, do butterflies have their taste buds on their feet as they taste with their feet?
Well, butterflies are insects, and of course they fly and visit various flowers and things because they drink nectar, and they do that through a long proboscis that they thread down into the flower. They have vision, so they can identify some of the flowers they want to visit by colour, but they also have a very good sense of smell. Butterflies, moths, other members of the Lepidoptera family, and they do that largely with their antennae. The antennae are the structures that project from their heads, and they are covered in nerve endings. These nerve endings are themselves bedecked with chemical receptors that can sniff the air. I don't know if butterflies actually have the same density of receptors in their feet, but it's not impossible that they may have some taste in their toes as well as in their antennae. But certainly most of the chemical sensation of scent is in those antennae, and so molecules coming off of the flowers and things they want to visit hit the antennae, and they can actually, because they have two antennae, they can resolve the strength or relative concentrations of the different things between the two antennae, and that tells them what the source is, because if it's stronger from the left than the right, they know they have to fly left in order to find the source. When they get closer to the source, then it might be that they could use their feet in order to sense out some of it, but I think most of their guidance is going to be smell, and then when they're in the vicinity, they'll use vision, and then when they've actually landed, they can feel through their feet, and they can certainly sense temperature that way, but most of it's going to be the antennae, I would say.
Thank you so much, Chris. We'll do it again next week.
Thank you, Eusebius. Thank you, everyone. Wonderful questions. Have a nice weekend.